Welcome to AP Physics Podcast. This is Chapter 10, question number 31. This is our first introduction to torques that we have in the homework. We are asked to find the net torque on this object given that our radius A is equal to 10 centimeters and our radius B, as shown in the diagram, is equal to 25 centimeters. Now, in order to find our net torque, we should find each of the individual torques, and we should remember that the equation for torque is that it is I times alpha, or in this case it is R crossed with F. Now, rarely has there ever been an AP Physics problem where you have actually been required to do a cross product, so most of the time we will find then that the magnitude of our torque is given by RF sine theta, where theta is the angle in between our force and our radius vector. Now that's a very important thing. So up here, we're going to find that our torque here is equal to our force times our radius. This is radius B here, so we end up getting 0.25 times our 10 Newton force, which ends up giving us a 2.5 Newton meter torque. Down here, we have a 9 Newton force that is again at radius B, so our torque here is 0.25 times 9, which is going to give us, very similar. It ends up being 2.25 Newton meters of torque. And as we then look at this one here, our 12 Newton force, our torque from that one is RF again. This one's attached to radius A, which is 0.1, and we're multiplying that by 12, so we end up getting a 1.2 Newton meter torque. Notice that we had all of our distances in meters, even though our radii were given in centimeters. And notice also that this 30-degree angle did not matter whatsoever. It was 30 degrees from the horizontal, but our force here, our 12 Newton force here, was still at a right angle to our radius vector. So it was still a 90 degree. So I didn't have any sine of thetas that showed up anywhere, because again, we should remember that the sine of 90 degrees is equal to 1. Now the question is, how do these torques combine? And so we should look at all of the clockwise torques. Torque net is going to be equal to our positive torques minus our negative torques. Our positive torques are all the ones that go in the counterclockwise direction. So torque counterclockwise minus the torques in the clockwise direction. So if we go up here and label these, this is a clockwise torque, this is a clockwise torque, and this one here is a counterclockwise torque. So our 12 Newton force is the only one that is a positive torque. These two over here are both negative torques, and so we find that our net torque is our 1.2 Newton meters minus our counterclockwise torque, or clockwise torque, which is 2.5 minus 2.25. So we end up getting a net torque equal to negative 3.55 Newton meters. So it will accelerate in the clockwise direction.